In the lesson today, you're going to have practice solving word problems that involve rational numbers. The key is to read the questions carefully and try to identify what the operation is going to be. Okay, so if we look at the first example, we're told that Bria filled a bucket with 3/4 of a gallon of water. A few minutes later, she realized that only 7/10 of a gallon of water remained. How much water had leaked out of the bucket? And that's what we're trying to answer. How much water had leaked out of the bucket? So we know how much she started with, 3/4 of a gallon, and we know how much is still in the bucket, 7/10 of a gallon. And to figure out how much has leaked out, we're going to have to set up a subtraction problem. So we're going to take the 3/4 gallon that we started with, and we're going to subtract off the 7/10 of a gallon that remains in order to figure out how much has leaked out. Remember that when you're subtracting fractions, you must have common denominators. If I'm working with fourths and tenths, I'm going to use a common denominator of 20. And so I can rewrite 3/4 as 15/20. 4 times 5 is 20. 3 times 5 is 15. Minus 7/10 is going to be the same as 14/20. I can multiply each of these numbers by 2. And now that I've got my common denominators, I can subtract these. 15/20 minus 14/20 is going to be 1/20. Okay, and so now we can answer the question. We can say that 1/20 of a gallon of water leaked out of the bucket. 1/20 of a gallon of water leaked out of the bucket. In example 2, we're told that Ramon made 5 sandwiches using half a jar of peanut butter. If each sandwich got the same amount of peanut butter, how much peanut butter did Ramon use on each sandwich? Okay, so it's important to understand what we're doing here. We're taking a half a jar of peanut butter and we're spreading it equally or dividing it amongst 5 sandwiches. And so that's what we're going to do in this example. This is a division problem, and we've got to make sure that we set up the division appropriately. We're dividing the half jar equally amongst the 5 sandwiches. And so our problem is going to say 1/2 divided by 5. And remember, you can make any number a fraction if you put it over 1. Okay, again, this is your half jar of peanut butter that's going to get divided up amongst the 5 sandwiches. And now in order to do this problem, instead of dividing by 5, I'm going to multiply by the reciprocal of the divisor. And that's going to change this problem into 1/2 times 1/5. Okay, nothing simplifies here, so I'm just going to multiply. 1 times 1 is 1. 2 times 5 is 10. And so I get this 1/10, which means that Ramon put 1/10 of a jar of peanut butter on each sandwich. Ramon put 1/10 of a jar of peanut butter on each sandwich. In example 3, we're told that there are 32 gems on a necklace and 1/4 of them are brown. How many brown gems will you need in order to make 15 necklaces? Okay, so in order to answer that question, we're going to have to first figure out how many brown gems are on one necklace, and then that can help us get us to the amount that we need for 15 necklaces. So I'm going to start by drawing a tape diagram here. All right, just going to draw a rectangle, and this rectangle is going to represent my 32 gems on the necklace. So at the beginning is going to be 0, at the end is going to be all 32 gems. And what I'm going to do is I'm going to split this up into fourths to help me figure out how many gems are going to be on each necklace. Okay, so if I break this into fourths like this, okay, well, I've got to figure out how many gems is it going to take to get all the way up to 32. Well, I know half of 32 is going to be 16. Okay, and so if I need just half of that, all right, in order to get my quarter here, I know that each piece is going to equal 8. There's going to be 8 gems in each piece. 8, 16, 24, 32. Okay, so I can see by using the tape diagram that 1/4 of the 32 gems must be 8. I could also get this answer if I use multiplication. If I'm looking for 1/4 of a number, all I have to do is multiply 1/4 by that number. So 1/4 times, in this case, the 32 gems. And again, I can make 32 a whole number by a fraction by putting it over 1. And now in order to do the multiplication, before I multiply, I'm going to simplify. 4 and 32 have a common factor of 4. 4 goes into 4 once, 4 goes into 32 8 times, and now when I multiply, I just get 8 over 1, or 8. Okay, and this is the number of brown gems per necklace. Okay, so I know that there are 8 brown gems on one necklace. I want to know how many I'm going to need in order to make 15 necklaces. So if I take the 8 brown gems that are on one necklace and I multiply it by 15 necklaces, this will tell me how many total brown gems that I need. And 8 times 15 is 120. And so now we can answer the question. You will need 120 brown gems for 15 necklaces. Okay, so there were 2 parts to this problem. First, figuring out what 1/4 of 32 was in order to get the number of brown gems on one necklace, and then multiply the 8 brown gems per necklace times 15 necklaces, and that tells you how many total brown gems you will need. In example 4, we're told that a store owner has 7 1/5 pounds of candy. If she puts the candy into 9 jars, how much candy will each jar contain? Okay, so the store owner is going to take all of this candy, the 7 1/5 pounds, and she's going to split it up or divide it amongst the 9 jars. So this again is going to be a division problem, and it's going to be 7 1/5 divided by 9. Again, the 7 1/5 pounds of candy being divided amongst the 9 jars. And so in order to do this division problem, I'm going to first change everything into fractions. 7 1/5 as a fraction is going to be 36/5 divided by 9, which is just 9 over 1. And now instead of dividing, I'm going to multiply by the reciprocal of the divisor. So this is going to be 36/5 times 1/9. And now it's a multiplication problem, but before I multiply, I can simplify with 36 and 9. Their common factor is 9. 9 goes into 9 once. 9 goes into 36 4 times. And now I can multiply, and I'm going to get 4/5. Okay, and so this represents how many pounds of candy will be in each jar. So we can say 4/5 of a pound of candy will be in each jar. Question 5 tells us that Bill won 7/8 of the 16 games that he played. How many games did he win? Okay, and so this was similar to an example that we did earlier with the gems on the necklace. I'm going to create a tape diagram, and the tape diagram is going to represent the number of games that Bill played, which in this case is 16, so I'll have 0 at the front, 16 at the end. Okay, and I know that he won 7/8 of those 16 games, and so I'm going to first cut it in half. Okay, half of 16 gets me to 8. Okay, and now I'm going to cut each half in half so that I have quarters. Alright, half of 8 is 4, so 8 plus 4, this must be up to 12 right here. But I don't need fourths, I need eighths, so I'm going to have to cut each one of these quarters in half as well. So I cut each piece here, and half of 4 is 2, so each piece here is going to represent 2. 2, 2, 2 all the way through. Okay, so this is going to be 6, 8, 10, 12, 14. So if I count up 1, 2, 3, 4, 5, 6, 7 of the 8 parts here, that's going to get me to 14 games. Bill must have won 14 games. And again, I can arrive at this, again, if I'm looking for a fraction of a number, all I have to do is take that fraction and multiply it by the number. So in this case, to find 7/8 of 16, I'm going to do 7/8 times 16, and again, I'll put 16 over 1. 8 and 16 have a common factor of 8. 8 goes into 8 once and into 16 twice. And now when we multiply, 7 times 2 is 14 over 1, which is just 14. So I can see with the multiplication that I get the same answer that I would get with my tape diagram. And again, this tells me that Bill won 14 games. In each of the previous examples, our rational numbers were fractions, and now we're going to look at some word problems that involve decimals. And one of the most frequently used places in the real world with decimals is money. And what we have here is a check register. This is what someone has to fill out whenever they're trying to keep track of how much money they have in the bank. We're told that on October 19th, Mark's bank account balance was $330. And so we're going to record that under the balance section right here. Okay, that's his starting balance, $330. And then we have a series of transactions. We're told that on October 20th, Mark deposited $125. And so we can see that recorded here. On October 20th, he deposited money. And now we're going to record that under the deposit section. He deposited $125. And when you deposit money, you add money to your account. So we're going to add $125. And now we'll get his new amount, 0.554. Now he has $455. On October 21st, 3 checks were written. The first one, check number 127, was for $175.85. So here's check number 127. When you write a check, that's a withdrawal, so we're going to record that here, $175.85. And now in order to get the new amount, we're going to have to do a subtraction. So we're going to subtract $175.85. Okay, and so now we're going to go ahead and subtract 0 minus 5. We can't do it, so this 0 is going to become a 10. This 0 is going to become a 9, and we actually borrowed from this 5, so we're going to turn that into a 4. 10 minus 5 is 5. 9 minus 8 is 1. Decimal point. 4 minus 5 we can't do, so we'll borrow. We'll make it 14, and we'll make this 5 a 4. 14 minus 5 is 9. 4 minus 7, again, we can't do, so we'll turn it into a 14 by borrowing from that 4 and making it a 3. 14 minus 7 is 7. 3 minus 1 is 2. So Mark has $279.15. Then check 128 was for $56.82. So here's check 128. Again, it's a withdrawal of $56.82. And we will subtract again. 5 minus 2 is going to be 3. 1 minus 8 we can't do. We'll turn it into an 11. We'll borrow from the 9 and make it an 8. 11 minus 8 is 3. Decimal point. 8 minus 6 is 2. 7 minus 5 is 2. And 2 minus 0 is 2. So he has $222.33. And now the last check, 129, was for $184.50. So we record that in the withdrawal column and we subtract $184.50. 3 minus 0 is 3. 3 minus 5 we can't do. That becomes a 13. This 2 becomes a 1. 13 minus 5 is 8. Decimal point. 1 minus 4 we can't do, so it becomes an 11. This 2 becomes a 1. 11 minus 4 is 7. 1 minus 8, again, we can't do, so that becomes an 11, and this 2 becomes a 1. 11 minus 8 is 3. 1 minus 1 is 0. And so now we can say that the balance in Mark's checkbook is $37.83. Question 7 wants to know what the new balance would be if check number 129 was for $284.50 instead of for $184.50. And so what we're going to have to do, we're going to have to take his previous balance, which was the $222.33, and subtract $284.50. Okay, well I can make this an addition problem. That's the same as $222.33 plus negative $284.50. These are different signs, so I'm going to have to subtract, and the number with the bigger absolute value goes first, which in this case is negative $284.50 plus $222.33. And again, these are different signs, so I'm going to subtract. So 0 minus 3 I can't do. I'll take that and make it a 10. The 5 becomes a 4. 10 minus 3 is 7. 4 minus 3 is 1. 4 minus 2 is 2. 8 minus 2 is 6. 2 minus 2 is 0. And then my answer is going to have to be a negative number because that was the number with the greater absolute value. So we can say the balance is negative $62.17.